Hello everybody, welcome back to the I Am IT YouTube channel. My name is Shabazz Dan. As ever, I am the IT geek. We are back in the Azure Stack series. We've started a new topic around planning and deploying Azure Stack HCI. So the first topic we kind of talked about different use cases and workloads. So we're going to continue on that topic. So this is part 2 today. We're going to do another demo. In the demo, we kind of deployed some more services, deployed some virtual machines, kind of showed the issue that I kind of had with our VM images for some reason. So yeah, without further ado, let's get started with this episode. So this is part 2 of the planning and deploying Azure Stack HCI topic. Today's episode, we're going to talk about planning for Azure Stack HCI workloads, then we're going to jump into another demo, just continue that configuration of my sandbox for my Azure Stack HCI. So after you verify that Azure Stack HCI is suitable for hosting your sort of workloads, you need to consider the infrastructure requirements, including compute, storage, and networking components. So general planning considerations for Azure Stack HCI implementation will include the number of physical servers per cluster. So this number can be between 1 and 16, as we're aware. The number of fault domains per cluster. By default, each node in a storage space's direct cluster is one fault domain. The number and type of the processor per server. Again, the first of these values sort of determines the core count, and the latter dictates their speed. Then have the amount and type of memory per server, including whether to use persistent memory or not. Also, we need to consider disk performance, including the corresponding tiering and caching configuration. And then we also need to configure the number and type of capabilities for your network adapters as well. The Azure subscription is also quite important because you'll need to register your Azure Stack HCI deployment with your subscription, because they're ongoing changes to the Azure Stack HCI cluster depending on the sort of Azure subscription type as well. Let's talk a bit more detail about storage capacity. So planning considerations with respect to storage performance and capacity are going to include the number of and types of disks, including HDDs, SSDs, and NVMe. Storage space direct resiliency levels as well as tiering and caching configuration. So these are all sort of storage capacity things you need to think about. Some of those networking factors to consider. First of all, whether to use network switches or go switchless. So small clusters can use full mesh network to connect to servers, connect servers to each other without switches. Also, physical cabling requirements for adapters, switched versus switchless again. And then the network switches per cluster and the ownership thereof. So again, all sort of networking factors and considerations that need to be taken into account. Talk about stretch clusters. So other considerations apply to stretched clusters, including how many servers each site requires and the cluster configuration node or mode. The two modes are active-passive mode, in which a designated primary site unidirectionally replicates to another site that provides disaster recovery capability. Then we have active-active mode. This is where two sites replicate their respective volumes unidirectionally to each other, providing sort of failover capability in either site if either site fails. The active-active mode helps minimize business continuity costs because you won't need a dedicated disaster recovery site basically. Let's talk a bit about planning for host storage. So in the simplest of terms, planning your Azure Stack HCI host storage involves identifying the optimal balance between resiliency, capacity, and performance of your storage spaces direct. However, there's a challenge. Maximizing one of these characteristics typically has a negative impact on at least one of the other two. So an example, increasing resiliency reduces the usability capacity, although resulting performance might vary depending on the resiliency type. Storage Spaces Direct supports hard disk drives, HDDs, solid state drives, SSDs, and non-volatile memory express NVMe drives, including PMEM. The choice of drive type typically affects storage performance due to differences in performance characteristics between each type and the cache mechanism as well. In general, Storage Spaces Direct assigns drives to one of two categories based on the drive type, capacity, or cache. We have capacity drives providing raw storage for your clusters and are typically slower and more sort of capacious than cache drives. Then I have cache drives that are used to accelerate reads and writes to sort of slower capacity drives. In clusters with multiple drive types, Storage Space Direct automatically assigns all the fastest disk drives and types to the cache and uses the remaining drives for the capacity. You can manually cache in scenarios where the default configuration doesn't yield optimal performance. Talk about drive symmetry now. Storage Space Direct works in the sort of optimal manner when every server has exact same number of and type of drives. In general, you should configure your Storage Spaces Direct cluster in such a way that all your servers have the same drive type, all servers have the same number of drives per type, all drives have the same model and firmware version, and all drives have the same of the same type have the same size. Talk about clustering quorum now. Clustering quorum pools. So in failover cluster, the term quorum is the number of clustering components to be available to the cluster to remain online. These components can include sort of cluster nodes and optionally a witness. The term witness specifies a resource dedicated exclusively to establishing and maintaining quorum. With Storage Spaces Direct, there are two distinct quorum mechanisms. With Storage Spaces Direct, we have cluster quorum, which operates at the cluster level and is based on sort of the votes from nodes and witness. Storage Spaces Direct doesn't support disk witness, leaving cloud witnesses and the file share witness as their two viable options. You then have pool quorum. This operates on the storage pool level and is based on votes and nodes and storage resiliency. To optimize pool quorum configuration when implementing Storage Spaces Direct, you need to ensure there's a matching storage configuration on each cluster. Finally, let's talk about, when it comes to planning for host storage, talk about volumes. So with Storage Spaces Direct, volumes allow you to sort of group drives in storage pools in order to yield the optimal combination of fault tolerance, scalability, and performance requirements. When planning Storage Spaces Direct volumes, you should really consider the number of volumes per cluster, file systems, volume size, reserve capacity, and resilience type as well. Before we get to the demo, let's have a quick discussion around planning for host networking. Again, in the simplest of terms, planning for host networking as Azure Stack HCI involves identifying the adapter and physical switch configuration you're going to use. Additionally, considerations for sort of stretch clusters include inter-site network POP requirements and latency. From a physical network consideration, at a minimum, customers must ensure they're using a compliant Azure Stack HCI switch, and they know the IP subnets and VLANs for the management, storage, and the compute traffic. Other network requirements, such as the data center bridging, might also be necessary to integrate into your network requirements for your solution. Let's talk about network ATC. So this is a new service that helps deploy and maintain the host networking configuration, and it's only available on Azure Stack HCI. It provides multiple benefits, including simplifying host networking deployment across the cluster, implementing the latest Microsoft validated best practices, keeps all host networking configurations synchronized with that cluster, it remediates administrative misconfigurations to prevent any configuration drift, and it streamlines sort of cluster expansion, helping to ensure new servers are deployed exactly as the other ones are. Talk about RDMA now. So RDMA is a key networking technology, and it provides high throughput, low latency communication that offloads networking traffic from the CPUs, freeing up CPU time for running workloads. The Azure Stack HCI configurations can use one of two common RDMA technologies. The first one is the recommended one, which is Internet-Wide Area RDMA Protocol, or IRAP, over TCP/IP, with TCP providing flow control and congestion management. You've then got the second, which is RDMA over Converged Ethernet, or ROCE, over UDP/IP, with data center bridging, DCP. Let's talk about software-defined networking before we get to the demo now. So Azure Stack HCI includes software-defined networking, or SDN, which can provide network services on your existing virtual local area network, or VLAN, based on sort of infrastructure, as well as virtualization of your networks and provide network services on the virtualized networks. Talk about some different scenarios for SDN with traditional VLAN networks. You've got microsegmentation, so customers can apply sort of security access control or ACL lists policies to protect their workloads from external as well as internal attacks. You've also got a scenario for traditional VLANs for QoS, quality of service. Customers can apply QoS policies to prevent one application or workload VM from hogging all the entire bandwidth of their HCI cluster nodes. You've also got SLB or software load balancing. So this is where customers can apply SLB to evenly distribute customer network traffic among multiple resources. SLB enables multiple servers to host the same workload, providing sort of high availability and scalability. We then have SDN scenarios with virtualized networks, so moving away from the VLANs but virtualized networks. That includes network virtualization, microsegmentation, QoS as well, SLB, virtual appliances, and connectivity to external networks. So, very detailed episode there, but we are time for the demo. And as normal, again, no set sort of no set agenda for the demo. We are literally just going to go and just continue with that configuration of our Azure Stack HCI sandbox. So let's jump into the demo portal.
Welcome back. We are here with another demo now. And if you remember in the last episode where we left it, I was trying to deploy an AKS cluster, and we were doing it through our HCI box. And if you remember, we had to go into the AKS, we had to open this in VS Code. And we had to change, there was a security group that I'd created, and we had to change it. So we put that in there. But what was happening was, if you remember, it was only last episode, so you should remember really. It wasn't connecting, so it was creating with an error, and it was all down to a logical network. And if you remember, I was getting that error. As you can see now, it's actually succeeded this time. So what I did was, again, you should see the link in the description, but the Azure Arc Jumpstart website, they recommend for troubleshooting, if you have any problems, you can load a ticket up into GitHub. So that's what I did. And someone very kindly looked at the code and found where the issue was, and they corrected it. So I kind of copied that code into my code as recommended, and it worked. So essentially what was happening was, if we go into this logical here, the IP pool wasn't being deployed, and for this deployment it needed an IP pool. So the code updated the code to apply the IP pool within the within the script, which then obviously provisioned my AKS cluster correctly. And as you can see, it's here. So just going to do some more setup with the AKS cluster now it's set up. So just if we go into here, we can see we've got all the overview. It tells you kind of what the agent version is, what the Kubernetes version is, etc. Some properties there. But then we can actually go look at the resources. So the namespace tells us what namespaces we have, the workloads. Now I'm no AKS expert, so don't expect me to know what a lot of these mean. But we look at storage as well. Again, you can add persistent volume claims if you want. You can add go to persistent volumes and add those. You can add storage classes as well. There's already got a default one there. Again, configuration just shows some of the configuration that's on the existing. If you look at we've got all the config maps here, secrets listed here. Now I actually want to set up some monitoring, but before I set up some monitoring, I actually want to connect to it. So again, just ignore, because I've just turned on my HCI box client, so that's why it just needs to catch up. Everything's working. If you look, all the nodes are online, etc. So just ignore that. So yeah, here I actually want to connect to it. So the code, I just want to click on capture the code. So this is a command. However, I just need to put in my actual resource group here. So the name of the resource group, which from memory is, where's the resource group? Should have it on the screen somewhere. I can't remember what my resource group is. Ah, there it is, yeah. So it's IT Geek HCI Box RG. Okay, so then if we just press enter on that, that should connect us in to our cluster. When I provisioned this, it did work. Famous. There we go. So it says proxy listening on port 4701. Filters. Make sure MSIs can pick correctly. Ah, right. So I had this error last time as well, and I actually need to do the AZ. I need to log in to. So this is a strange thing which I found. Even though I'm logged into my tenant here, as you can see, and I've loaded the Azure CLI and I've connected to Bash. You still need to do the command to connect. So we'll do that command, and then hopefully that should authenticate, and then we'll redo that command to connect to the AKS then. So it's the AZ space login command that we need to do. And then it says to open that in a new. Let's try and, so is it an image? Okay, let's just try and select that. I'd like to copy it if possible. Okay, so let's, oh, it's opened it as a new image. That's very funny. Okay, so let's go to https / where was it? Here, wasn't it? I could just click on it like that. And then we need to enter the code. So the code was this here. I'm being lazy, so I'm just gonna. So let's go with that. Let's continue, and there we go. So that's logged in now. So I should send. There we see it's logged me in. Perfect. So I should be able to just go up a couple of do that same command now. Again, does that proxy is listening on port, and then it should connect me to. There we go. So we're connected now. So this is where I can actually start doing some sort of like commands. So again, I'm no AKS expert, so you're gonna have to pardon my oh. So we can start doing cube control requests. Press Control C to close proxy. We don't want to close proxy quite yet. So let's do a cube CTL get nodes minus O y. Let's try and see if that'll show us the actual nodes that are in the. So there's a reason it wasn't working. We actually need to, if we go up to the top here, we need to actually click on new session. So that opens up a new session, and this is where actually the actual command kubectl CTL commands. So we'll just set that load. And then we'll have kubectl access to our cluster. This is where I can do the just do our commands really from here. So let's do it again. So let's go kubectl get nodes minus O wide. So hopefully that retrieves. Yeah, there we go. So that's what. So this is just connected to our AKS cluster finally. You open a new window because we don't want to be in that proxy window, and it gives us all the information. All of it is there, just do a command to get the nodes. So then you can do all any kubectl commands that you want, and that'll then allow you to manage your AKS cluster through Bash or PowerShell. So yeah, just wanted to do a quick demo on actually managing and showing how we can. So it's been provisioned successfully, and we've been able to manage it. You know, all we did was get nodes, but able to manage it through the AKS cluster, or manage the AKS cluster through our PowerShell or CLI Bash the portal, or you can actually connect to it from a, from PowerShell if you've got that installed on your machine. Make sure you authenticate though. Even if you're logged into CLI through the portal, you do need to authenticate and open that new window once you've connected to the AKS cluster and start doing your commands. So yeah, thank you very much for watching. I hope you're enjoying this this video series. Obviously, I'm really enjoying it. I'm learning as I go along. That's why it's a bit stop and start with the demos. This is not technology that I've dealt with before from AKS. It's nothing I've done before, even in my professional career. So I hope you're enjoying it. I got a bit of feedback on some of my videos that I do. My intros are a bit too much about me, so I'm gonna roll it back a bit with the demos. Or even all my videos as well, and not do as talk about myself as much. So hopefully you guys will enjoy it a little bit more. So anyway, thank you for watching. Till next time. Goodbye.